Welcome once again. So the idea of today's webinar is we're going to be talking about vector operations in Microsoft Excel. Now, what is this vector operations? I'll come to that. But before that, I'm going to talk about one of the problems that we have in working with Excel for a lot of financial calculations. And this is what I call as a problem of dimensionality. If any of you have attended, I had attended my program on mathematical aptitude, I might have talked about the same problem there as well, right? So what is this problem of dimensions? So if you look at this one, let us say, I actually had a client. I had a client who was running a play school, lots of branches. Each branch has multiple classes. And we had to kind of look at, branch wise, let's say profit and loss statement. When we are looking at a statement like that, how did it look? This is how it looked like. I mean, when beginners build a model like this is how the statement looks like. So for each branch, I have to have 5 columns: play school, nursery, junior KG, senior KG. And below each column, I will have sales, expenditures, rent, all your expense. And you're going to have something like this for 25 branches, right? So if you ever want to do a comparison of, let's say, branch 10 versus branch 3, you have to go specifically. You're going to have 25 into 5 columns. That's 125 columns. You have to go specifically, select the branch 5 column and come to the branch 10 column, do a comparison. It is going to be a pretty complicated thing to achieve. So what is our alternative? An alternative is to go for a vector operations. Now, what is this vector operation that I'm talking about? Just one second. Let me give you an example with another example that I have right below. Here, what I have is I'm talking about bond valuation. I'm starting with a simpler example here. Now, I don't know how many of you know bond valuation, but essentially in case of a bond valuation, what is going to happen is I have to do a formula to find out if these are the bonds. I have 3 bonds here. Each of the bonds give me different cash flows, and I am supposed to value these bonds. How do I value it? Now there is a formula. Even if you don't know the formula, it's okay. Now the formula is you have to find out an expression for each of the value. So the expression is going to be, these are all cash flows, right? These are all what the bond is going to give me. So the cash flow divided by 1 plus the interest rate raised to the power t. T is for time. So if I want to do it for bond 1, I have to do calculation here, 8 divided by 1 upon 4, 1 plus 4% to the power 1. So I have to do this calculation. Now, once I get this number for all the values, so this is going to be for first bond, right? I will have to sum it up, right? What is big deal about this, right? We all know about putting the necessary dollar sign, and I can now have this and just copy paste it. It's so easy. So what is the challenge here? The challenge is what is happening in terms of our file is that we are now dealing with, sorry, I should have put a dollar in one more place, right? So you had rows and columns, right? That is our vector. In Excel, that's the 2 dimensions you have, a row dimension, a column dimension. Now, what is going to happen is here to get one data for a bond, I have to calculate 1 column I have to keep for the bond. And now I'm having one more dimension, one more, which is present value. And the problem is across my columns, do I have similar type of data? Answer is no. You cannot say, okay, across my row also, I don't have similar data. Across my column also, I don't have similar data. Why? In one case, I have percentage. In one set of columns, I have absolute value. And in one set of column, I have present value. Now, when you're dealing with smaller number of data, this may not look like a problem. But when you go to a much larger set of data, you will have an issue very similar to what we have here. If I had given you a setup like this and said, there are 2 branches and I'm doing a calculation, whatever little that you probably appreciated now when I explained to you about the problem, about the number of lines, you would not have appreciated it if I had given you 25 columns as such. If I had given you only 2. Now, Vector operations can be a solution to us here. Now, what is this vector operation? In vector operation, but before I go about vector operation, let me talk to you about certain terminologies that I'm going to use here. So when I talk about a scalar unit refers to a single cell, right? So when we say a scalar input, that means I'm taking a single cell as an input. When I say a scalar output, that means I'm taking a single value comes out as output. So scalar means it's one value. So you may take a scalar input or you may have a scalar output. Vector refers to a column of data. Even though here I'm actually using the word vector operations, but I'm referring to both vector as well as matrix in a way. A vector is basically a column of data or a single column which can keep growing. Similarly, it can refer to a single row which can keep expanding horizontally. We call both of them as vectors. So vectors automatically adjust their size. If I have 5 values, the 5 can automatically become 50 values as well. Those are the things that we call as vectors. What are matrix? Matrix essentially refers to a table with multiple rows and multiple columns. So what I'm looking at here, this is a bond matrix, right? I have a bunch of bonds with their values, multiple rows and multiple columns. These are matrix. We also talk about array. An array is basically bunch of values. That's what we call as array. Now, what is the difference between an array and a matrix? Now, what I have here is an array, but I'm also calling it as matrix. So between an array and a matrix and a vector, what's the difference? The difference is a matrix can grow, a vector can grow automatically, array does not grow automatically, right? That is the problem with arrays. All right. So that is just about the terminologies that we're going to be using here. If you have any questions or any thoughts, you can feel free to put that in the chat section. You can also unmute and talk. There are only 6 of you here. We can very well unmute and talk. Any questions, any thoughts? All right.
Not at the moment. Thank you very much.
Okay. Hey, hi, Sthanamurthy.
Hi, everybody.
Welcome. Good, good. How are you?
Good. I'm good. After this, we'll talk.
Yeah, sure. All right. Now let's come and talk about vector operations, right? Those of you who attended the mathematical thinking, probably you would have seen the vector operations there, because what we always say is that, when you come to a problem of dimensionality, there are 2 solutions to it. 1, vector operations in Excel. 2, mathematics, right? Mathematics will help you to reduce the number of dimensions. A problem which has 5 dimensions or 4 dimensions, you can reduce it mathematically. And vector operations helps us to handle dimensions. When you have a lot of data points, it helps you to handle it together. So now let's see how I'm going to handle this part. So what did we do here? I calculated present value of each of the individual cells, right? The present value calculation is essentially, I took one value. So column D divided by column 1 plus C to the power B. This operation, what I did is a scalar operation. I'm operating on single cells, and the single cells gives me one output. How does a vector operation look like? What I'm going to do is, I am going to give one single formula here where I'm going to take all these values, D51 to D54, divided by 1 plus B51 to B54, sorry, C51 to C54, raised to the power B1 to B54. This is what I'm going to give. Now this one formula would give me all the 4 values that we just talked about. And this is what we refer as dynamic arrays. Now dynamic arrays came only in Office 365, but even before that we could have used it. How? Why other function Excel would have given you a problem? Let me just quickly open Office at my end. Right, and I will show you what could have been done with the Open Office version, because Open Office does not support Microsoft dynamic array. Let me just quickly open this. Right. Okay. Now, what we could have done is, rather than getting 4 values, I could have combined them into one. I could have wrapped it in a sum function. And the sum function would have given me a single value. Just one moment. Yeah. So what I could have done is I could have wrapped this inside a sum function, and the sum function would give me a single value, right? So rather than having 4 rows and 1 extra column, I could fit this within one single cell. So which means for my bond 1, now I have only 1 column, right? I don't need 2 separate columns, because tomorrow somebody would say, I want to do a present value comparison with absolute value comparison. Now, no big deal. I mean, if you want to do the comparison, I would do it in one single column right here. It's not going to, so your present value, I mean, what we called here, this formula, the summation is 90% of your total, right? I don't have to think about where all to go, where all to pull up the data. Especially if we have hundreds of bonds, then you will have 100 bonds, and then there will be another 100 which will have a complementary values. I don't need that here. One single column is all enough. One bond, one column, my data is sorted, right? This is what we call as vector operations. Now this vector operation, as I just mentioned, it was possible even in the older versions where you don't have this dynamic array concept. So let me just paste it here. So here also what I could have done is I could have put equals. I mean, so OpenOffice did not support vector operations. So if I did or rather it doesn't support dynamic arrays. So here if I did all the values divided by all the rates raised to the power all these numbers, it would have thrown an error. It said, I can't do this because this, you're dealing with multiple values, that's going to throw multiple outputs. It's not that it cannot do the calculation. It is that it cannot throw the output, because in one cell you can give only one output. But what we could have done is, I could have, if I'm going to get the aggregate of this, in the older versions, you had to use some product function to work with arrays. So if I was supposed to get an aggregate of this, the aggregate is only one number, that one number would have come out, right? And this way, it would have been very easy for us to actually do this calculation for multiple bonds in one go. Now this is about the power of vector operation. So what vector operation is going to do is I can get rid of everything. So for one, say, data, I don't need multiple dimensions. So here what is happening is, for bond 1, I have multiple rows, which gives me multiple, I have multiple rows so that I can put multiple cash flows. I also require 2 columns. That means I occupied 2 dimensions for one single bond. Row dimension was occupied with cash flows. Column dimension was occupied by different types of data. One present value, one absolute number. We have removed one of those dimensions. Now I have multiple rows, but only one column. And when you use this approach, we can get rid of problems like these things, because the main idea of vector operation is reduce the number of dimensions. Okay. Now, we will not go too advanced today because this is the first session. So what I'm going to be doing is I am going to teach you essentially, I gave you an introduction to what is vector operation and its power. So what I'm going to do is I'm going to talk to you about how you can use different approaches in vector operations. In Excel, most of us work with one approach, which is scalar operations. Scalar operation is your end output is only one value. Occasionally, you may use a function like a sum or a sumIfs, which takes range as an input, but the output is only one value. Most of the time, we only work with scalar operations. Today, we are going to learn how to work with vector operations. And here we'll also first understand the difference between vector and an array. So the first example I'm going to do is this, where what I have is a very simple set of data. In this data, what I have is, I have quantity and price of certain products. I'm going to get their sales. Historically, what we would do is, we will do it as scalar operation, quantity times price, do the calculation, sum it up. Now, if somebody says, I want the price in dollar terms, right? I want everything in dollar. What we would do? Take the Indian rupee price divided by the dollar, and I got it for one cell. Now I want it for 3 different products for 3 different currencies. So that means I'm going to have 9 different formulas here. Each cell is a different formula, right? This is how we traditionally work with Excel, which is entirely scalar operations. Now, how does a vector or a matrix operation come into picture? Let's learn this. Firstly, let's talk about array operations. Now, what's an array operation? In an array operation, what is going to happen is I'll do it in open office so that it's something we can, because it doesn't support dynamic array. So we will see its problem here. So in dynamic array, what I'm going to do is rather than selecting 3 different values, right? I mean, 3 formulas, I'll select this entire range equals. I'm going to select all the 3 quantities, multiply it with all the 3 prices, right? If I press enter, it's not going to work because these older versions did not have the capability to throw multiple values. So if you wanted this, you had to use Ctrl+Shift+Enter. When I use a Ctrl+Shift+Enter, I have got all the 3 formulas coming here. I've gave one formula here, C24 to D26 times D24 to D26. I've got the answer. Now this is a array. The problem with array is array cannot be easily resized. So you notice that I cannot change an array. I cannot delete it. I cannot copy paste it. It's not going to work. I cannot copy this and paste it here. That's not going to work here. So what do we do here? So for example, tomorrow, if there is a donut that is added, now if I try to put that number here, 50 and 40, now that doesn't come here. And if I want to now include 4, my problem is I have to delete everything that I had and redo this entire problem. Equals 360 times this, Ctrl+Shift+Enter. This is an array. The array was not very popular mainly because arrays were very rigid. I cannot even insert a row in between. If I try to insert a row, it is going to throw an error to me. If I went and tried inserting a row, see, it doesn't even allow me to insert a row. It's grayed out because it's an array. Vectors, on the other hand, will allow us to resize. So let's see how I'm going to work with vector here. I'm going to put equals the 3 quantities and I'll multiply it by the 3 prices. One formula, no Shift+Enter, nothing. I press enter. All the 3 values have come, right? Now, if I had to insert something in between, let us say there is another biscuit here, let's say a Bourbon, and there I have 200 quantities and 10. I could easily insert something while my array automatically grew. I didn't have to do anything to my formula, right? So this is what we are doing here in terms of working with vectors. Any questions here up to this point?
This is just a quick one. So basically what you're saying is once we use CSC, that is Ctrl+Shift+Enter, that basically locks the entire structure and you can't do anything, no insert possibilities.
No insert, no delete, the size gets fixed. You can't do this. I mean, if you want to resize it, you have to delete the entire array and then go and resize it. Right? It cannot automatically resize itself. That's the problem with arrays.
All right. Thank you very much.
Right? So vectors in Excel context, we call it as dynamic arrays. Vectors can automatically resize, vectors as well as matrix. All right. And we call them as dynamic arrays.
Yeah. Can we, how can we paste the formula in the 28th cell as in E28? If we
E25, 26, 27 doesn't have any formula actually.
No. I'm talking about E28. Suppose if, like the previous example we did in the open office, suppose if donut comes in below cookie, so the formula would automatically take it, or we need to do something as in that is what I'm asking.
We will be talking about that in the next section, right? We will be talking about that in the next section, what happens, right? Now here it's not going to happen. I inserted Bourbon. If you look at it, how my vector expanded because I inserted Bourbon in between, right? Now, this approach to dynamic array that we are working with is not ideal, even though a lot of people who seem to have picked up dynamic array still seem to be working this way. It is not ideal because, as you rightly pointed out, tomorrow if there is going to be a donut that I'm going to add here, 50 and 20, this donut doesn't get picked, right? My data expanded, my formula didn't expand. So what is the architecture we need to follow for that? That is what we're going to do a little later. Example 3 and 4 comes into that picture, right?
Okay. Yes.
Now, but before I go into more, let's understand vector operations, how they work. So now these four are vectors, right? So I'm doing a vector versus vector. We saw what happened. Now I gave C24 to C27 multiplied by D24 to D27. How did Excel know which item in this array should be multiplied with which item? It picked up corresponding values, C24 with D24, C25 with D25, C26 with D26, C27 with D27. That's what it did. Now what I'm going to do is I'm going to operate on this vector. This is a vector. On this vector, I'm going to operate with a scalar. So I'm going to divide this by 10. Now what happens? I'm going to press enter now. You will notice that all the values, this one scalar affects all the values. All the values are going to be divided by 10 here, right? So one scalar, there is a vector. When I do a vector times vector, corresponding values get multiplied. When I'm using a scalar unit, what is happening is this scalar unit operates on all the vectors equally, right? All the items here are getting divided by that same value 10. Is it clear? Any questions? Just give me one moment. Just give me one moment. Let me just change the position. So this is what we discussed. So what happens when you operate on a vector with another vector? These two vectors, corresponding elements happen. But when you use a scalar, that single scalar element divides all the item. Now let's talk about another scenario where my two vectors, I'm using two vectors here, but they're of two different sizes. So my quantity vector is 3 items and my price vector is 4 items. Okay, I seem to have got some question here. I'll answer this question. I'll come to this question. So if you look at it, my quantity vector has 3 items, C37 to 39, whereas my price vector has 4 items, C37 to C40. What is going to happen now, right? Because if it was scalar, right? If I was dividing it by 10, I'll divide all of them by 10. Here, both of them are vectors, but they're of different sizes. What is going to happen is the first 3 items will get evaluated because there are 3 elements here and there are 4 elements here. So first 3 items in my second array will be operated with the first 3 items in my first array, but my second array has one extra item, that 4th element, for which there is no corresponding value in the first array, and that throws a NA error to me here. Okay. Is it clear? Any questions?
Suppose if donut has a 0 number, but if you don't apply the formula over there in C column, if you just put 0 or 1, anything.
But as long as it's not selected in my formula, it's going to be a problem, right?
Okay.
So unless if I had selected C37 to C40, it's okay. If it was 0 here and I selected both the arrays have same number of elements, calculations will happen. 0 times 40 is going to be 0. But if the first array does not have those 4 elements, as only 3, then the 4th element will return a NA error saying that you're operating on 2 vectors, but for the 4th item, I don't see corresponding values. Clear? Now, just to answer, I could even have this vector. So far, we were talking about row versus row. You can even use a row and column versus column also you can do. So if I were to say all these 3 multiplied by 7590 multiplied by 1, 2, 3, I'll have answers. This time the answer will spill horizontally. 75, 200, 270. See, in Office 365, the answer spills. In the older version, it would throw a value error, but you could still aggregate them. You could aggregate them using a sum product or average or some other function and then get one single output out. That's possible in the older version as well. Clear?
Can we do it a mix of rows and columns?
Yes, that's the next thing we are going to do. So what is it that we have learned so far? We learned vector versus vector, what happens? We learned scalar versus vector, what happens? Now, we also learned what happens if irregular vectors are operated, irregular size of vectors. The next item, what we're going to do is we're talking about, see, vectors can be a row vector or a column vector. Now, let's talk about a situation where what happens when I operate on a row vector with column vector. So what I'm going to do is, I'm going to take these 4 values, right? Why does a hash sign come? Because this, all the 4 values here were obtained using one single formula. So this is a part of a spilled range. That's what is the term we use. So if you're referring to an entire spilled range, that hash sign will come. It says you are referring to a range that spills from E24. I'm going to select this and I'm going to divide it because I have to divide it by the exchange rate. Now what is going to happen, right? Because here is one column vector and I'm operating on one row vector. It's going to throw a matrix to me. So it's going to take 288 by 75, 288 by 100, 288 by 90, 540 by 75, 540 by 100, 540 by 90. Same thing, 200 by 75, 200 by 100, 200 by 90, and so on. That's what I'm going to get. So you notice that this one formula has given me an entire matrix. I made a mistake here. Crores should be not divided by 10. If you want to convert a crore into million, I should be multiplying it. Yeah. But that's okay. That doesn't affect our knowledge of array or vector operations. So when you use a row vector with a column vector, every element of the row vector will be operated by every element of the column vector. And that means we'll end up getting a matrix. Clear? Any questions?
What if the column is not an outcome of vector, as in instead of selecting E column, if we go select the D column, then would it throw the matrix?
Yeah, it doesn't matter. It will still throw. It does. Excel doesn't know our mind, right? Excel doesn't know why we are looking at E versus D. Excel's job is you're giving a row and you're giving a column. It'll throw the output to you. Okay. Right? It doesn't matter. Why I selected E, why I selected F, that logic is only in my mind. It's not communicated to Excel yet. Clear? Any questions here?
No.
All right. Now, just for the sake of discussion, okay, let's do one more thing here, which is one second. We are now going to, we learned these 4 things. The next thing I'm going to talk about is what happens when, I mean, even though the webinar was titled Vector Operations, let's talk about also matrix operations. Now, say I've got these items, right? Now, let's say I want to, these are all in millions. Now, here I'm taking a matrix, this entire matrix, and I'm going to multiply, divide it by 10 so that I get the data in crores. Let's say I want these values in crores. Now, here is an entire matrix. On that matrix, I'm operating on it with a scalar, with a scalar unit. What do you think is going to happen?
You're going to get a matrix, entire matrix.
We'll get an entire matrix. The entire matrix is going to be divided by 10.
10.
Right? All the values there are going to be divided by 10. Right? So what we have learned is when you use matrix versus scalar or scalar and matrix, either ways, that scalar unit will be applied on all the elements of the matrix. Right? The 10 is going to apply on entire unit of matrix. Right? That operation will happen. Now, what happens if I were to, let's say, operate on this matrix? I'll delete this. Here is a matrix. This matrix number, let's say I'm going to figure out what would have been my sales in, let's say, price in dollar terms. So here is a matrix and I am operating on the matrix with a vector C24 to C27. What is going to happen now? Right? Now, every row, so in this case, if you look at it, the vector is a column vector. And since that's a column vector, every column of the matrix will be operated by the column vector. So that means I will get 384 by 360, 720 by 450, 266 by 200, 640 by 240. That will be one column. Next column will be 288 by 360, 540 by 450, 200 by 200, and so on, right? So this is what I'm getting. So this is probably my price in dollar. I should divide it by 10 because the data there, sales is in millions, whereas quantity is in crores. So here is what we are looking at as our price in the respective currency terms. Right. So I'll wait here for a minute. If you have any questions, let me know. And I hope I've answered all the questions that has come my way so far. Any other questions that has come, I missed out, please remind me. Okay. Shall we move on? Any other questions, thoughts? Now, just a teaser at your end. What do you think would have happened if I had selected 3 rows of the vector? My matrix has 4 rows, 3 columns. I'm choosing 3 rows of the vector. What do you think would be the result? Based on whatever you've understood so far, any thoughts? What would be our result here?
Any error on the last row?
Yes.
Yes. So the first 3 rows will get operated and I'll have any error on the last row. Absolutely right. One more trick question. What if I had selected only 2 columns here in the matrix and not 3 columns? What would have happened?
Any error for the third column?
No, you will get only 2 columns of answers.
Yes, yes.
The last row will still be an error, but because keep in mind, our vector is only 1 column, right? Our vector is only 1 column. I mean, this is a vector. That means it has only 1 column. So both the columns here will be operated by that one single column, and I'll get 2 columns of output. Okay. Because it's a vector on a matrix, right? So there is nothing that's going to be different here. There is third column. There is no reason to give the third column. First column by the vector, second column by the vector. That's going to be our answer. Third column is not anywhere in the picture. All right. So we learnt vector on matrix. What happens? Before we go to the proper architecture, let's also understand what happens when you work on a matrix with a matrix. Now, actually, I didn't have matrix with matrix in my mind when I started the webinar, but since I just realized when we were just based on the last answer, I thought we should cover that part as well. So just for the sake of discussion, what I'm going to have is, let's say I'm going to have a matrix here, 3 by 4 matrix, right? Or a 4 by 3 matrix. Let me have that. Now I'm going to have one more matrix here, which is going to be another 4 by 3 matrix. Maybe I'll have a matrix of even numbers. In the previous one, I had a matrix of running numbers. Here I'm having a matrix of even numbers. Now, what happens if I'm going to operate a matrix on matrix? Both the matrix have same number of rows and same number of columns, right? 3 rows and 4 rows and 3 columns. Here also 4 rows and 3 columns. So what do you think is going to be our output here?
Because it's a simple addition and because the matrices are identical in row and column, we're going to get one new matrice, which is a 4 by 3 matrix basically, because it's an addition.
It's simply going to be a line. element to element addition.
Absolutely.
First item here versus first item here, second item versus second. That is what we're going to get, right? 1 plus 2, 3, and 2 plus 4, 6, 3 plus 6, 9, and then 4 plus 8, 12, 5 plus 10, 15. This is the data point we are getting here. All right. What would happen, let's say, if this matrix had an extra row or an extra column? What do you think would be happening here?
We get NA again.
Yeah. So what is going to happen is, here I'm going to have 5 rows and 4 columns, whereas the other one has 4 rows and 3 columns. So which means there will be 1/5 row will not have a corresponding element in my second matrix. 4th column will not have a corresponding element in my second matrix. So the 5th row and the 4th column will turn NA here. Right? So the 4 rows and 3 columns, you have a corresponding items in both the matrix. Wherever you don't have corresponding items, they all become NA. Right? Now, in general, most of the time when we work with matrix operations, if you're going towards dynamic array, if you're working, we would want to ensure that these kind of irregular shapes are avoided. But sometimes things are not under your control. Sometimes the way the data flows, irregular shapes come into picture. In those cases, what you can do is you can handle these errors. So if I have a NA error here, what I'm going to do is I'll just put if NA, open the bracket. So if this turns out to be an array, I want alternative something else. What do I want? Let's say I want a 0. So the if NA function, wherever the NA error comes, not available error comes, it's going to give me an alternative. If it's valid number, it's going to get me the data. If it's not valid, I'm going to get alternative data. I'm going to get 0 here. So sometimes you may have to use this as an error proofing, because if you think, okay, my end users are going to make some mistakes, then we can apply this option.
This is just a quick one. Instead of using if NA, we can also use if error also, right? There's the same thing. But in this case, since we know the resultant error is NA, so we can use if NA. But otherwise, if you're not sure, like it could come as value or as something.
So I normally discourage if error function because if error handles all types of errors, right? Now in this case, the only error that I know can come, which should be handled, is the NA error.
Okay.
If some other error comes, that probably means I should go and test the source data if there is something wrong in the source data. So I generally discourage if error, but technically you can use it. Technically you can use if error, but I generally discourage that.
One more question. Now, since we've taken a simple addition case, instead of this, if it was a multiplication, what would have happened?
Same, line to line. This is not line, element to element multiplication would have happened. This is not a matrix multiplication. If you want to do matrix multiplication,
that was what was running in my mind. No, that was what was running in my mind. Is it going to do a matrix multiplication like we did in our 7th or 8th standard mathematics?
Yeah. So this is going to do element to element multiplication. If you want matrix multiplication, you are supposed to use mmult. Mmult stands for matrix multiplication. And that is what we would do here if you want a matrix. Right? So this, because matrix multiplication, all it cares is that the number of rows, columns in the first matrix should be equal to number of rows in the second matrix. That is satisfied here. 4 columns in the first matrix, 4 rows in the second matrix. Matrix multiplication works, and we get 3 rows, 3 columns and 5 rows of data.
Okay.
Right? So if you want matrix multiplication, we are supposed to use mmult. In a later session, we'll talk about matrix multiplication because we use a lot of matrix multiplication. In dynamic array models, when I build, I use extensive amount of matrix multiplication. It'll be required. So, but that we'll discuss in another webinar specifically on this. All right. Now moving on. So we understood how data behaves. Okay, I thought we'll be wrapping it in half an hour. It's already 45 minutes. We'll then take another 15 minutes and we'll wrap it up. Now let's come to proper technical architecture of these dynamic arrays, how it should work. See, if you want to exploit dynamic arrays in its entirety, what we need to do is we need to avoid static ranges. My ranges here are static. So what would have happened is if I had added donut here, which we saw, when I add a donut here of 50, the donut did not come into picture at all, right? If there was another currency that my team wanted to look at, let's say they wanted to look at sales in JPY for whatever reason, or SGD, and they wanted $50. Now my data is not flowing. My reports are not flowing at all. So I have to ask someone to copy paste the formula, or in this dynamic array, at least make some modification, extend this, right? And here also go and extend this. Right? I had to do this. This is manual effort at the end of the day. We don't want this. And especially in a dynamic array, more so discourage this manual work, because people assume that if it's dynamic array, it's going to all automatically update. You don't have to copy paste. In a pure scalar approach, at least people are mentally prepared. Yes, if anything happens, I should copy paste. Here, you've prepared people saying that one formula gives all the results. So nobody wants to copy paste it. So the original design that Microsoft also, when they announced their dynamic array, what they said was this, that when you're working with dynamic arrays and when you want to use vector operations, what you do is, if your data is input, keep the input in a table, right? So the input is going to be in a table. Let me not have donut for now. Let me remove donut from my list. So my table has these three values. You keep the input in a table. Certain calculations can happen within a table, right? So in this case, because what happens in a table is a table automatically expands, right? I have 360 times 8, 450 times 12. I have the data. So when I add one more element here called donut, my table automatically expanded. And when I type the values, you notice that my data automatically comes into picture. Right? I didn't have to do anything else. So table is not it behaves like a vector, but it is basically an automated set of scalars. So every time I add a data, Excel is doing two stuff. So I can show it to you. Let me copy and paste this just to show you what is happening. So donut 500 and 240. Let me copy this and paste it here. When I pasted it, what you noticed is automatically the value came. But actually speaking, let me do a Ctrl+Z and you will see what's happening. When I do a Ctrl+Z, you notice that what I pasted is remains there, but the value is not coming. So the way table works is, you do a step, then Excel does the next step automatically, right? So when I do a undo, the Excel step is undone, right? That is what is happening here. But it's still very useful to us, unless somebody is going to intentionally rig a table. Table works almost like a dynamic array for us, right? But as far as the architecture is concerned, the idea is keep your inputs in a table. So your inputs can automatically expand. And your inputs are going to be organized as a table. So I'm not going to have earlier I had the USD GBP exchange rate arranged here. I'm not going to do that. How is it going to work? This input is also going to be in another table. And I am going to pull all of them using a dynamic array formula. So what I'm going to do is I'm going to say, the products I'm talking about, again, let me not have donut into this list. We'll add donut later. Right now my table doesn't have donut. So when I say table doesn't have donut, you see donut there. So why am I saying table doesn't have donut? My table ends where you see this inverted L bracket. That's where my table ends. So donut is now outside the table. So we'll expand the table later on. So what I'm going to do is I am going to get my products by using a formula. I'm going to say, in this table, pull out all the products for me. How do you interpret this expression? Product is the name of the column. Table 55 is the name of the table. Who named it table 55? Excel gave a default name. I can change it. I can select this box, go to the table design tab. I'll change it as, let's say, sales data. So now if you look at the formula reads sales data. That's the name of the table. And column is product. And for value, I already have the rupee value here, right? So INR value is simply going to be what I see here. Now, what am I going to do about USD, GBP and Euro? I am going to get them like this. Transpose of these currencies. If you know what a transpose function does, it converts rows into columns, columns into rows. So here USD, GBP and EUR are three different columns. I mean, they are in three different rows. Let me close it. They have become three different columns now. Again, the name of the table is table 68. I didn't give the name. Excel gave that name. Let me rename it. Let me name it as, let's say, FX table. Right. Now, how am I going to get USD, GBP and EUR? How am I going to get this rate? XLOOKUP has been there for almost 2 years. I'm not sure how many of you over know it. I'll just very briefly tell you what an XLOOKUP can do for us. So if I want USD values, I'm going to put XLOOKUP. I mean, let's say I'm going to get the exchange rate. I'll select this USD. And I'm going to look up for this USD in this table and pull out my rates. So wherever USD comes, it'll pull out that rate. Right. Now, instead of USD, what happens if I refer to all the three columns? Now, keep in mind, I did not give three columns here, by the way. If there was a SGD, it would have automatically become 4 columns. If my table only had 2 rows, Excel would only give me 2 columns here because I'm transposing whatever is there in the table. So if the table has 4 rows, all the 4 will be transposed and I'll get 4 columns. If it has only 2 rows, only 2 will be transposed and I'll have 2 columns. So what I'm going to do is I'm going to say, do a XLOOKUP for which currency? I'm going to say, not which currency, all the currencies. Right? D52 hash. This hash sign indicates that I am looking at a spilled range starting there, comma, look for them in the currency section and pull out the rates. So I've got all the 3 currencies in one place. Right? So now what am I going to do? I will not, this XLOOKUP, I showed it to you to see how XLOOKUP pulls up all the 3 values. Any questions, by the way, before I move on? Because we are getting into a slightly more complex territory.
Sorry, I don't know how to do it in a table. Value which it's a basic question, but I'm not aware of.
No, it's a very important question you raised. So what happens is when you have a bunch of data, right? If you want to make the bunch of data into a table, what you do is select that area, go to insert and mark it as table, right? So see, this is already a table for human eye, but Excel doesn't see it as table. Excel doesn't know whether these are all the 9 are related elements or are they independent elements. Excel doesn't know. When you mark it as table, Excel recognizes this as a table. And how do you recognize your data as a table or not? As my user marked it as a table or not? 2 ways you can find out. Put your cursor inside a table. If it's a table, you will see this table design tab automatically coming. And one more thing you can see is you can see this inverted L arrow. Color is not concerned because you may have it as a table and I may still not have colors there, right? I may still have it as a plain, boring bunch of cells. This looks like a regular cell, but it's a table.
Yes.
You see this inverted L and you see the table design tab, right?
Got it.
So it's not about shading. It's not about colors. That is just an extra added advantage. All right.
Okay. Yes.
And if you want to name the table, you can go to it. So the idea here is when you're working with dynamic arrays, store your inputs as tables, right? And in a table, there are a few elements that we have to understand. In table, you can have either an input column or you can have a formula column. So here, when I put one formula in one single cell, that formula automatically gets replicated everywhere else, right? Sometimes if you want to do some small, jugaad and you want to add some 50 or something in some cell, you can't do that. It'll add 50 everywhere, right? You can't do that saying that, okay, only in this cell I'll add it, because sometimes I see some companies when they prepare their final accounts, the accountant, if the balance sheet doesn't tally, just adds a 0.5, 0.2 here and there to tally the balance sheet. You can't do those things with table, right? It requires sanctity here, right? All right. Any other questions? Okay. So now let's see how I'm going to get this. So what I'm going to do is I'm going to say, take this 3 sales again, because keep in mind all the 3 values came as one single formula. So that means they are all part of one single spill range starting at cell C53. So I'm going to say C53, add a hash sign divided by exchange rate. I'll again do XLOOKUP, because originally I would have put the XLOOKUP only here. I would have said, XLOOKUP for the currencies, look at the currencies and bring their exchange rate. Which currency? All the currencies starting at D52. There is a spilled range, look at all of them. In this table, in the currency column, look for them in the currency column. Once you find out where the currency comes, pull out the rates. Press enter. I've got all the 9 values, right? Now this is what we got earlier also. So what is the advantage here? The advantage is tomorrow if somebody adds donut to my list, you notice that I've got donut sales also in table. Already gave me data in rupee terms that has come in the table itself. But I could also get USD, GBP and Euro. And let me also do one more thing. Let's say tomorrow my team says, I also want to analyze it in SGD and get me the SGD exchange rate. Now, once that SGD, I'll type it all over again, because when you type it, the table automatically expands. Last time I manually shrunk it, so it's now not expanding. So SGD 55 is the exchange rate. I've got the answer, right? So all that my team needs to do is, my team should not, what you need to be careful is, don't keep anything to the left of your table. Right of your table, if you think your table can expand on the right side, and don't keep anything to the bottom of your table if you think it could expand at the bottom. So because let's say somebody gave me their phone numbers and I typed the phone number here. Right. That's my own number. Right. Let's say somebody did this. Now what is going to happen is, right? Now what's going to happen is, when I added one more currency, let's say AED, you notice that there is a spill error. Why is there a spill error? Because it says, now I need 6 columns. There are 6 currencies, which means it's all going to automatically spill. So it's going to say, I need 6 columns, but we don't have 6th column. 6th column is not free. We have 6 columns, but the 6th column is not free. Something is occupying it. All you have to do is just delete this and it'll work, right? If something is occupying the space, something is blocking the space, it throws a spill error. So when you're working with it, what I generally do is, I keep this dynamic array in a different sheet on the table elsewhere, and I ensure that nothing comes to the left, to the right. I'm sorry. You can put anything to the left. It doesn't matter, because arrays are going to expand to the right. And similarly, I don't keep anything to the left. Keep anything on the top. It's okay, because again, arrays don't grow top, they grow down. So I don't want to keep anything at the bottom. I don't want to keep anything at the right. All right. Any questions? Any thoughts?
Can we have the currency rates in another sheet, like some other sheet saying rates?
Absolutely, right. That's frankly how I maintain my architecture. The inputs are in a different sheet altogether. My calculation is in a different sheet altogether. Right.
Just a basic question, as in, instead of doing this all set of functions in the previous sheet what we did, can we do it with the help of table itself, multiplying the currencies versus the value?
Good, very important question that you asked. Can I do it in table? Not going to be possible. Why? At least not without destroying the sanctity of a table. Because in a table, as I told you, a row is either going to be an input row, or it's going to be a formula row. A column. A column is going to be an input column or a formula column, right? So if you try to bring in this USD, GBP, etc. here, now what happens is the sanctity of the table gets lost. So if I'm going to put, USD, GBP, and let's say Euro, if I'm going to put 50, 60 and 75, 100, 90. You may do it, but it actually destroys the sanctity of table, how it works. So if I'm going to say value divided by F53, right? It's not working like that spelled range, because it's, in fact, it should throw an error here saying that, because one data here is the input. In one single column, I'm mixing input and I'm also having a calculation. The table is not working like a table anymore. As you can see here, when I copy paste, it is not spilling on its own, right? So theoretically, yes, you can do it, but then it defeats the entire purpose of working with a table, right?
Okay. So in a table, we can only take one input and the other should be an output, as in that way, correct?
Not that way. A column can either be an input column or a calculation column, right? One column cannot have two data points in itself, right? I mean, one column cannot have two characteristics within itself. It's either an input column, like this 360 and 8, these are all input columns.
Yes.
And this one is a calculation column. So, and the calculation has to be consistent. You can't have three different calculations in one single column, right? So one column will have only one calculations. Okay.
Okay.
So just to add to what you said, so if the traditional way of keeping, let's say, our financial statements, sales, COGS, gross profit, can I keep this as a table? Answer is no, not in this order. Because here what is going to happen is, if I'm going to have a calculation like this, my sales is going to be an input, cost of goods sold is going to be a input, gross profit is going to be a calculation, right? Again, you can do it, but it destroys the purpose of keeping it as a table. That is the main problem for us, right? How would we do it rather?
Viz, if I can.
Yeah, go ahead.
Yeah. Buddy, I don't know your name. Just a point. Understand the concept of table. There is something which we look at databases. There's something called normalized value versus denormalized value. This is a bit technical, and I'm sure Viz will take it up in future sessions. But the point being that a single row or column is for one purpose only. It cannot be for multiple purposes, in simple words, so that it will be either storing value as input or storing value as output in the form of a formula. It can't do both in the same row or column, whichever way you look at it.
In a table, it is about column. Row is going to be, so here, if you look at it, the way it's going to work is one column can either be an input or one column can either be a calculation. So in these kind of situations, how we will have to organize, if you want to organize your financials into a table, it has to look like this, 1000, 1100, 900. I'm just putting some random numbers here. So my gross profit is going to be sales minus COGS, right? This works holding the functionality of table. Here also I did something like that, but then it defeated the purpose of a table. It became like a regular Excel cell. Nothing automatic happened there. Clear?
Yes.
Okay.
Yes.
Okay, it's already 1 hour. I'll very quickly just wrap up the last part here. When you're working with vector operations, one of the things that we can do in Excel, especially in Office 365, is take our calculations to the next level where, if Excel has to work like an app, what we need to do is we need to make our Excel sort proof. What I mean by sort proof is these days, we deal with large number of data and people keep sorting the data. I had a client who was like, in a real estate sector. The client first said, I want to view the data by, let's say, the tenants. And then said, okay, you know what? I don't want alphabetical order of tenants. I want it in the descending order of the carpet size. Of the leased area, right? Now I'm going to keep sorting the tenant list to see who comes on top, who comes, to look at the data point. So if my formulas, when I'm giving, should not go for a toss when I give that formula. Now I'll show you an example of where it could go for a toss. Now I have my Sensex data from 15th July to 20th July, right? It's actually not 15th July to 20th July. Let me sort this here properly first. 1st July to 30th July, I have the data. Now, if I'm going to calculate growth rate, daily returns. Now, the way normally we calculate daily returns is current cell What does this @ indicate here, by the way? Because you know one thing, in a table, if you refer to a column, it refers to the entire column, right? When you use @ symbol, it refers to current row of the column. That's what the @ indicates. So instead of saying I'm not looking at the entire column, I'm looking at current row of the Sensex column. So a lot of time what will happen is people would put a C6 upon C5. C6 is today's value divided by C5 minus 1. Now, when you're working with Excel, when you do something like this, what is the problem is, this is going to give you correct answer as long as the previous days in the previous cell. C6 by C5, C7 by C6. So as long as the previous values in the before cell, the answer is correct. If somebody were to sort this in a descending order, or let's say I'm going to sort this in the alphabetic ascending order of Sensex. Now this is gone for a toss. My 7th July number is comparing now 7th July price divided by 16th July price. Pointless. I mean, why would anybody want to do that, right? All your calculation goes for a toss. Here again, vector operations can help us. How? In a vector operations, when you're working on it, you either, when you select an element, it's either in the same row, the element you're specifying, either select data from the same row or the entire vector. I am not going to pick and choose a value. So I will not say C6 by C5. I'm not going to do that. I'm going to, at Sensex, this is current row. I can select that. I'm pulling data from the current row, that I can do. But I am not going to pull data for the previous day. I'm not going to go and specifically select the data, because that is not allowed here. I mean, if you want sort proof, either pick the data from the same row, any other data you want to pick up from elsewhere, you have to refer it through a structural reference. How? So if I wanted previous day's price, what I'm going to do is, I'm going to say, no, lookup for today minus 1 in this date array, right? So in the previous case, I mentioned C5. Now I'm going to say not C5. I'm not specifying C5 here. I am looking for previous day's price. How do I specify previous day's price? Today's date minus 1, comma, in the date column. I'm going to say today minus 1 would be previous day, right? Look for the previous day in the date column and pull out the Sensex value. Our formulas are going to get lengthier. That way you type is going to make your work a little longer. But the point is, this will ensure, of course, this formula is not done yet. I'm still going to get some errors. No problem. I'll explain that. But this will ensure that even when you sort your data works fine. Now, what's the error I'm going to get? I should have, of course, done minus 1. What is the error I'm getting? The error I'm getting is because 5th July minus 1 is 4th July. And 4th July was a holiday. It's not in my list. So it says, 4th July data is not there. In that case, in XLOOKUP, put a double comma. The 4th element is, I'll cover it maybe in another day. In the 5th element is where we're going to say, if the data that you're looking for is not there, 0 means if the data is not there, it'll throw an error. If I put minus 1, then 5th July minus 1 is 4th July. If 4th July is not there, it's going to look for the next lower item, whatever comes just before 4th July in my list. So 4th July is not there. Just before that, in my list, what I have is 2nd July, and it is going to give the answer, right? So in the XLOOKUP, I have to put comma, minus 1. Now this formula structure, if you look at it, maybe you can just note down one of the dates. 7th July is 0.37%, right? Let's sort the data again, largest to smallest. 7th July, what's the price? 0.37%. Last time, if you look at it, it did 7th July divided by 16th July. Here I'm getting exactly correct answer. So our formulas become sort proof, right? So what vector operations or array operations can do for us when we apply the proper principle is reduces the dimensions of your problem, what I talked here. And when your data dimension is reduced, you can build far more, scale your Excel file a lot more. And your Excel file can start working like an app, what we did here in this case. So I can ask my team to add as many currencies as they want in the future. I can give this task to an intern. I can tell them, add your products or add the currencies. Tomorrow, if you want, let's say AUD, and you want to put, let's say 52, no problem. The moment AUD got added, my data got added, right? Your Excel starts working like an app. And as part of that, if you want it to work like an app, what is important is your Excel should be sort proof, because these days we deal with large data and people love to sort the data. I mean, you might, whatever dashboards, pivot table, anything you can give, eventually, when I sit in review meetings, that's what happened. They come and say, no, I want to see the raw data, sort it and show it to me, right? We go there, sort it, filter it and show it to them. And you don't want your data formulas to go for a toss when you sort it, right? And that is, again, another place where vector operations can help us. Okay, I thought 40 minutes. We have 1 hour and 10 minutes. That's fine. I mean, no issues at my end. Any questions, any thoughts? That's the end of the agenda for me today. Any other questions, any thoughts? All right.
Thanks.
So, yeah, sorry, go ahead.
No, I just wanted to thank you. Thank you.
Yeah, welcome. What I would recommend is, I'll send a small feedback form. You can also share a feedback form about the webinar. And I would also suggest, if you have some thoughts about what kind of topics can be covered in a webinar, right? Let me know, probably, because I do plan to do one at least every month. The last one I did was last September, I think. Then I'm doing one today. I thought I'll do one every month. So if you have ideas, please also share that with me and we'll do one. All right.
Yeah. Thanks a lot. I learned a lot today, you can see.
Great. I mean, good to know that. And yeah, welcome. All right, then. If there are no other questions, thoughts, I'll stop here. Thank you very much for joining. And yeah, please do fill up the feedback form, and please, more importantly, share suggestions about what else would you like to see covered in a webinar, and we'll talk about that in the futures. All right. Thank you. And whatever is left of your Sunday, enjoy the Sunday and have a great week ahead.
Good night. Thank you very much.
Thank you. Bye-bye.
Bye. Now, can I call you now?
Yeah, we can in the Zoom call.
Now phone Lookup, I'll call you in a minute.
Okay, sure.
Good night. Bye-bye.
Yeah, bye-bye.